Day everyone. Today we are going to tackle about Poisson distribution. Poisson distribution is a discrete probability distribution. It gives the probability of an event happening a certain number of times within a given interval of space or time. We can use Poisson distribution. Number 1, individual events happen at random and independently. That is, the probability of one event doesn't affect the probability of another event. For example, of an independent event, tossing a coin and rolling a die. Number 2, you know the mean number of events occurring within a given interval of space or time. This number is called lambda, and it is assumed to be constant. One of the first applications of the Poisson distribution was by statistician Ladislas Bourgeois. In the late 1800s, he investigated accidental deaths by horse kick of soldiers in the Prussian army. He analyzed 20 years of data for 10 army corps, equivalent to 200 years of observations of one corpse. He found that a mean of 0.61 soldiers per corpse died from horse kicks each year. However, most years, no soldiers died from horse kicks. On the other end of the spectrum, one tragic year, there were 4 soldiers in the same corps who died from horse kicks. Using modern terminology, a death by horse kick is an event. The time interval is 1 year. The mean number of events per time interval, or the lambda, is 0.61. The number of deaths by horse kick in a specific year is k. Poisson distribution formula, as it is presented, that the probability of x to k is equivalent to the Euler's constant to the power of negative lambda multiplied by lambda to the power of k all over k factorial, where x is a random variable following a Poisson distribution, k is the number of times an event occurs. Probability of x to k is the probability that an event will occur k times. E is the Euler's constant, approximately 2.718. Lambda is the average number of times an event occurs, and the factorial sign is the factorial function. For example, a student receives an average 7 text messages in a 2-hour period. Question: what is the probability that the student will receive exactly 9 text messages in a 2-hour period? Using the formula, probability of x to k is equivalent to the Euler's constant to the power of negative lambda multiplied by lambda to the power of k all over k factorial. So p, the probability of x, which is equals to 9, is equals to Euler's constant to the power of negative 7 multiplied by 7, which is 7 text messages in 2-hour period, which is the lambda, the power of 9, all over 9 factorial. That is equivalent to 0.1014 or equivalent to 10.14%. So there's a probability that the event will occur for 10% or 10.14% that the student will receive 9 text messages in a 2-hour period. Another question: same average or same mean, 7 text messages in a 2-hour period. What is the probability that the student will receive exactly 24 text messages in an 8-hour period? since it is an 8-hour period, not a 2-hour period, so we are going to find the ratio and proportion of the 7 text messages in a 2-hour period and 24 text messages in an 8-hour period. So we have the lambda sub 1 is to the time sub 1 is equals to lambda sub 2 is to the time sub 2. So we have 7 is to 2 is equals to lambda sub 2 is to 8. So using ratio and proportion formula, so that is 2 multiplied by lambda, that is 2 lambda sub 2, then 7 times 8, which is equals to 56, divide both sides by 2, so we come up with lambda sub 2, which is equals to 28. So we are going to use the formula of Poisson distribution. So probability of x is equals to 24 equals Euler's formula to the power of negative 7 multiplied by 28 to the power of 24 all over 24 factorial, and we come up with 0.06095 or approximately 6.01%. Another example. A business receives an average of 8 calls per hour. What is the probability that the business will receive at most 5 calls in 1 hour? So when we are dealing with at most, at least, so we are dealing with inequalities. So that is the probability of x, which is less than or equal to 5, is equivalent to the Euler's formula, Euler's constant to the power of negative lambda, multiplied by summation of lambda to the power of k over k factorial from 0 to 5. Since we are dealing with at most 5 calls, so we are dealing with 1 call, 2 calls, 3 calls, 4 calls, until 5 calls. So we have this one, Euler's constant to the power of negative 8, multiplied by the summation of 8 to the power of 0 over 0 factorial plus 8 to the power of 1 over 1 factorial plus 8 to the power of 2 over 2 factorial plus 8 to the power of 3 over 3 factorial plus 4 plus 8 to the power of 4 over 4 factorial plus 8 to the power of 5 over 5 factorial. And we come up with a probability of calls received, or at most 5 calls received in 1 hour, of 0.1912 or equivalent to 1912 or 19.12%. So how about if the question is finding the probability that the business will receive more than 6 calls in 1 hour? So a while ago we are talking about less than. Now we are talking about more than. So that is 1 minus the probability of x less than or equal to 6. Since we are dealing with more than, so the opposite of greater than is less than. So if we're going to add the numbers less than or equal to 6 and more than 6, the probability of that event is equals to 1. But since we are dealing with more than 6 calls in an hour, so we're going to minus it by 1, or the probability, which is 1, minus the probability of x less than or equal to 6. So using Poisson distribution, 1 minus E constant or Euler's constant to the power of negative lambda, summation of lambda to the power of k over k factorial from 0 to 6. So the probability of x more than 6 or greater than 6 is equals to 1 minus e to the power of negative 8 multiplied by the summation of 8 to the power of 0 over 0 factorial plus 8 to the power of 1 over 1 factorial plus 8 to the power of 2 over 2 factorial plus 8 to the power of 3 over 3 factorial plus 4 plus 8 to the power of 4 over 4 factorial plus 8 to the power of 5 over 5 factorial plus 8 to the power of 6 over 6 factorial. And we come up with this value. The probability of x greater than 6 is equals to 0.6866 or approximately 68.66%. For your exercise, you are going to answer this one. At a small walk-in clinic, an average of 5 patients arrive at the clinic per hour during opening hours. First question, what is the probability that exactly 3 patients will arrive in the next hour? Second question, what is the probability that less than 4 patients will arrive in the next hour? So that is all for our topic, Poisson distribution. Hope you learned something from our presentation.